Okay. So let's look at example 243. So basically they are saying we can afford a $200 per month as a car payment. So if you can get an auto loan at 3% APR for, 5 years, 60 months, how expensive of a car can you afford? So basically they're asking us, how much loan can we pay off if, our limit is $200 a month on the car payments. So obviously, we're talking about figuring out the present value over here. So and again, just to remind you guys, remember we said the future value will be zero, right? Because we'd be paying off the loan. And so obviously in the future, once you've paid it off, our balance should be coming out to zero. So that's why you will see at the end of this formula, you've got a zero in that parentheses. So we're basically saying, okay, using that present value formula, we know that we are getting a 3% loan. All right, so we are getting a 3% APR, so that of course becomes 0.03. Normally you are making monthly payments, and we did say we can afford to pay $200 per month. So that's the 12. And then 12 times 5 for the number of periods, right? And then of course, we're saying our regular payments will be $200 and your future value should be zero. So based on that, when we plug that into the PV formula, you can see we're basically saying that we can get a loan of $11,130.47. So of course, then if you look at the textbook-based formula or the regular formula, you can see that's the same dollar amount. You're going to come up with $11,130.47. And then basically the idea is if you wanted to calculate your interest based on that, well, you're making $200 payment for 5 years every month, right? So 200 times 5 times 12. That means we're actually making a total payment of $12,000. And if out of that $11,130.47 was our loan amount, then of course that means we're paying an interest of $869.53. So kind of similar in the examples we had done with the savings in the last section. All right, how about a mortgage? So in this one, we are talking about you want to take out $140,000 mortgage home loan. The interest rate for that loan is going to be 6%, and this is for 30 years, which is kind of the normal time frame for a mortgage loan. How much will your monthly payments be? What percentage of your total payments will go towards the interest? So kind of the similar example. So obviously, in this case, we know the loan amount, we have to figure out what our regular payments will be. So you can see in this instance, we are using the PMT formula. So you've got a 6% interest rate, so that's the 0.06. Of course, we're making monthly payments, so dividing it by 12. 12 months times 30 years, and then of course, our total amount of loan or the present value is 140,000, and same logic, right? Our future value is going to become zero. So that last argument is zero. So this is showing us that if we take a mortgage of $140,000, the monthly payments will be $839.37, right? And then again, you can see the traditional formula when we try to figure out what our regular payments will give us obviously the same dollar amount. Now, to figure out how much interest we have paid. So if we are paying $839.37 each month for 30 years, 12 times a year, right, for 12 months, you can see we are actually making a total payment of $302,173.20. Subtract the 140,000 from it, that's the loan we borrowed. And you can see we're paying double the loan amount in interest, right? $162,173.20. Did you have that?
Yeah, it's just kind of a question about the question.
Okay,
If we have a question that asks, like, you want to have this much by this time, account earns this much percent interest. But doesn't say how often it's compounded, do we just assume that it's annually,
Monthly.
monthly?
And we did actually talk about that last class, so just remember that if they are not specifically mentioning a compounding period, but you know, it is that same idea that you're taking out a loan and you have to pay it back. If they don't specifically tell you a compounding period, then monthly is the default. Okay, so just keep that in mind. All right, guys, so once we figure out how much interest we have paid, then to know what percentage of our balance. So in this case, when we're talking balance, it's not the loan amount we took out, right? It's how much total payments you've made. So it's going to be that interest we calculated divided by how many total payments we've made. So, you know, our total value, and you can see that comes out to be approximately 53.7%. And like I said, we are paying more than the amount we borrowed, right? So right at 50% would be if you were paying 140 in interest, but since we're paying more than 140 in interest, that amount is going to be higher than 50%. All right, let's look at an example and then we'll come back and do these other types of problems. So all right, let's look at 9. I like that. So this guy is talking about, and yeah, we will use the built-in functions. We're not doing the formulas. Just because, like I said, sometimes those can get a bit too much. Oh, I did not open up a spreadsheet. Let me go ahead and open that. While I'm getting that spreadsheet open, again, remember how Samuel had asked if you guys could create your own spreadsheets ahead of time. So if you want to do that, that's fine. You just need to make sure you are sharing that with me on the day of the exam so I can see how you did your calculations. If I cannot see your calculations, you will not get full credit on your question. So you will need to share those spreadsheets with me. Also, just to again let you guys know, the exam has to be taken in person, so you cannot take the exam on Zoom. So please make sure you are physically here in the classroom on the day of the exam. All right, so let's get this into our spreadsheet here. Hopefully you guys can see that. All right, let's paste this. Well, you're trying to buy a house. I think that's all of it. Okay. So if we have saved a down payment amount, as you can see here. It's the word compounding that's kind of being hidden, but we're okay. So we have $20,000 saved as a down payment on a house. We wish to take out a fixed rate 30-year mortgage loan at 4% APR. And again, we're assuming that it's monthly compounding. They are asking us if the maximum mortgage payment you can afford is $950 per month, what is the maximum house price that you can afford? So let's start out with what information do we have? So we know we can make regular payments of $950. And again, I'm going to format that into our dollar value. And I'm calling it D to keep it with the notation from the textbook, right? So just kind of keep that in mind. Why? And that's your payment. So I'm just using this formula. So the D is that regular payments we do. Okay. All right. So fixed rate is 4%. And again, we're going to format that into percentage, make sure it's 4% and not 400. Alrighty, 4%, and then what else? We know compounding is gonna be 12 because we're doing it every month. And this is going to be a 30-year mortgage, right? Alrighty, I think that's all the information we have. Oh, and we do have a down payment of $20,000. So again, change that into a dollar amount. Is that all the information? I think so. So between PV and PMT, which formula do we use to calculate how much loan we can basically borrow, or how much the maximum price of the house can be that we can afford? PV or PMT? PMT? Anybody else? People on Zoom, do we have an opinion, PV or PMT? Do we know the PV to use the PMT formula? And PMT is the payment, right? PV is the present value. So to use the PMT formula, we should know what the PV is, right? Which is the amount of loan. Do we know how much loan we are going to borrow? No, but we do know the maximum payment we can make, right? So it's actually the other way around. So since we know the maximum payment we can make, you are actually using the PV formula to figure out how much loan you can take out. So it's going to be the PV formula. So that's PV. And then the first one is rate. So remember that is R divided by N. So R divided by N, comma. Number of periods is N times T, comma. Then your payment amount, which we know we can do a maximum of $950. And then of course, since this is a loan, your future value will be 0 because you're going to be paying it off at the end of 30 years. So I'm going to leave that up for just a second, so you guys can see the values I've typed in there. So again, remember your rate is R divided by N. Your number of periods is N times T, and then your payment amount, and then of course, future value will be 0. Okay, I'm going to hit enter. And again, it gives you that negative value. So remember how I showed you to make it positive, just do equal to, put a negative sign, and then click on that cell where we just calculated. So negative times negative will become positive and it'll end up giving you a positive. So, if we need it in other calculations, we don't have to worry about making it positive then. So we're just going to go ahead and make it positive now. So we're basically saying the home that we can purchase can be, is it the 198,988.18 cents that we came up with? Or is it going to be minus 20,000 or plus 20,000? Because the question is, what is the maximum house price that you can afford? Because we know they saved, or we saved $20,000 for a down payment, right? So would we add that to this dollar amount of PV, or would we subtract? Because you make the down payment of 20,000 and then the remaining you borrow. Or is it we're saying, since we said the maximum mortgage payment we can make is $950, and based on that, we came up with 198, almost 199, $199,000. Does that mean that's the loan we can take and then we add the 20,000 on that for the down payment? Because 950 is the payment amount, right? We're talking about. So this is what we can comfortably give the bank to pay off our mortgage loan. So which makes sense, to add 20,000 to this and we can say, oh, we can go up to a $200-something thousand home. Or do we say, you know what, we can do 198, but if we do 20,000 subtracted from that, your payments will actually go down. No, it's going to be add, because they are talking about specifically that the maximum mortgage payment you can make is 20,000. So your maximum house price would be price. Will be the PV plus the 20,000. Because it may not seem like 20,000 is enough, but again, if you're familiar with the real estate market a bit, that can be a difference between a house you really want and a house you're compromising with, right? Because 20,000 in that sense is a very big dollar amount when it comes to buying homes, right? I mean, it can be like, can I afford something that I have to fix? Or can I afford something that, you know, is kind of move-in ready? And so I think that's where that would make a difference. So since we are saying we can afford paying $950, that means your loan amount would be $198, but the maximum price can be plus that 20,000. Does that make sense, guys? Yeah? Okay, what other question would there? Is that it? Just what is the maximum house price? I guess so. They didn't want to know interest or any of that. Okay, questions, guys, on this breakdown? Okay, so far? Alrighty, let's see. Let's go back to our remaining loan balance here. Okay, with loans, it is often desirable to determine what is the remaining loan balance after some number of years. So if you purchase a home and plan to sell it in 5 years, you might want to know how much of the loan balance you have paid off and how much you will have to pay, you know, from the sale of your home. So to determine this remaining loan balance after, you know, how many ever years, we actually first need to calculate our payment amount, if that is something we don't know already. And the only portion of your loan payments go towards the balance, the loan balance. So the idea here is, a portion is going towards interest, a portion is of course going towards, loan balance. So if your payments were, let's say, $1,000 a month, after a year, you will not have paid off 12,000 of the loan balance. Okay, so how much of that is not paid off if we calculate it at the, you know, whatever time period? So let's take a look at this guy here. So to determine the remaining loan balance, we can think how much loan will these loan payments be able to pay off in the remaining time on the loan? Okay, let's take a look at an example. So if we have a 30-year mortgage, which is again at an interest rate of 6% APR, our payments are $1,000 a month. After in 5 years, what will be the loan balance? Alrighty. So we're talking about regular $1,000 monthly payments. We're saying the rate of interest on that mortgage loan is 6%. Of course, since monthly payments, your end will be 12. And then since we're talking about after 5 years, what will be the loan balance in 5 years, which means you've made the payment for 5 years, you've got the 25 years remaining, right? So that's where that T equals 25 is coming from. So going back to our PV formula, you will basically see 6%, 12 for the end value, but the T has now changed, right? Instead of 30 years, we're talking about the remaining 25 years. And then of course, you're making regular payments of $1,000, future value is 0. So that actually gives us the dollar amount, $155,206.86. So basically here, the idea is that is how much will be left on our loan, right? If we were to buy the house and sell it in 5 years. So this is what we would need to repay the bank. And that actually happened with my cousin, because he decided to move back to India and sold his home. I think they had lived there for 5 or 6 years, right up there. So whatever the purchase price he got, it's not like he got to keep all of it, right? Because the bank would be like, hey, dude, where's my money? So he had to pay off whatever was the balance on his loan. And then on top of that, what was left from his sale, he got to keep that. So, you know, that's of course something kind of the scenario we're looking at. So basically they're saying sometimes answering remaining balance questions can be broken into 2 steps. So we start by calculating the monthly payment on the loan, and then we calculate the remaining loan balance. And remember, bless you, that's going to be based on the remaining time, right? Not the original time that you took the loan out for, but how much is going to be left if halfway between that you sell that property. So let's see if we can find an example on that. Okay, there we go. So let's look at this fellow. Let's bring it in. Wrong statement. Alrighty, so this is our number 13 over here. Okay, so assume you take out a 30-year mortgage loan. So again, your time in years. And again, like I said, 30 is kind of the standard time. We are talking about a loan. So that's going to be your present value. And again, you can call it P or PV. Okay. And this is the 250,000. Let's make sure we have enough zeros in there. Change that to a dollar amount. Your fixed APR is 4.5%. Again, we'll need to make sure that's 4.5. Alrighty. Okay, so they want to know, and again, by default, your N is going to be monthly payments. Okay, so what will be the amount of your monthly payment? So go ahead, calculate that and let me see what you come up with. So if you're figuring out the payment, which formula are you using? And then tell me the dollar amount once you have. And for these examples, remember, we're not using the formulas from the textbook, right? We're just using the built-in ones. Because again, I don't want you to have to like go through all of those detailed calculations, since we do have the option of using a spreadsheet. So what will your monthly payment look like if we took out a loan of $250,000 at 4%, 4.5% fixed APR for 30 years? Yes.
466.71 cents.
Okay, so 1266.71. Can anybody verify if they have the same answer, or if you have a different answer than 1266.71? That's what you came up with? Okay. So this is what we have. So which formula did we use to come up with that number? PV, PMT? PMT, yes, because you're talking about finding the regular payment. So that's going to be the PMT formula. So again, your rate will be R divided, R divided by N, comma, number of periods will be N times T, comma, present value, of course, is the $250,000, and then your future value will be 0, because we should have paid off. And you can see, yeah, very nice. $1,266.71. So again, you want to make that into a positive number, so equal to negative, and then I'll just click on the cell. So that should change that guy to a positive number. Formula? Okay, so we do have our regular monthly payments here. So that was part A. Then part B is asking us, after the first 10 years of payments, how much will remain on your loan balance? So after 10 years of payments, how much will remain on your loan balance? So I'm gonna just give you guys a second to write down that formula so you have it for your record. Try something, I'm curious to see. If I wanted to make this guy by default. Look at that. Okay, so this is what I did here. I just wanted to see, which I thought it should work. So instead, because you know, PMT by default also gives us a negative answer. So when I'm typing the PMT in, I actually put a negative sign in front of the word, the command PMT. And that also actually helps you change that into a positive number. So that's the other thing you can do if you didn't want to do like, you know, two different calculations. So I'll leave that in there so you guys can take a look at that. All right, so after 10 years, what will be the remaining loan balance? And remember, this is the example that we just looked at. Right here. So in this case, you would now be using the present value formula, right? Obviously, the rate, the end value will stay the same, the payments will stay the same. It's mainly going to be the number of years you're calculating it on, right? So that's what we will need to do to figure out after 10 years, how much is our loan balance. So you are using the PV formula. Because you're kind of figuring out what the present value will be, right? At that time period to figure out the loan. So I'm actually going to do equal to, and same thing, put a negative sign in front and then do the PV function. So it will help us give a positive answer by default. So your rate again is going to be R divided by N, comma. Number of periods, of course, is N times, what's my T value now? No, because it's after 10 years. So what was our total 30-year, right? Yes. So it's gonna be 30 minus 10. 20. You know what? I'm gonna just click on a random cell right now because that's where I'm gonna put in our 20 years. All right, let's see. So this will be payment amount is the 1266.71 that we just calculated, comma, your future value, of course, will be 0. It's not gonna give us anything right now because my cell over here is 0. So this will be 30 minus 10, so after. So you can see even after 10 years, your loan has not significantly decreased. I mean, yeah, by 50,000, but not like halfway or anything like that, right? Because you started out with a loan of $250,000. You've been making regular $1,266.71 payments every month for 10 years. And that only brings your loan value down to 223.59. And remember, this is because how we had talked about those initial years, most of your payments are going towards interest, right? It's only towards the end of that time period that it starts going more towards the principal. So that's what's happening. You're actually paying more towards the interest right now than you are towards the principal that we borrowed. Okay, so this was after 10 years. Now they want to know after the first 20 years of payments, what your loan balance will be at that point. So this is after 20 years. So that's of course 30 minus 20. So basically for the last 10 years is what we're looking for. So for the last 10 years or after 20 years, what is our remaining loan balance? Okay, so same thing, you are calculating the present value at that time. So I'm going to do equal to negative sign again so that we by default can get a positive answer. PV function, Rate, same thing, R divided by N, comma, number of periods would be N times T, which in this case will be, what did I do? N times T. Remember, this is after 20 years, which means your time at this point is only 10 years left. Comma, your payments are still. That's a good question. Do we still leave it at 1266? I guess we do. That was the original payment, comma, your future value will be 0. Seriously, we still haven't gone like the last $50,000 or something like that? You're still at $122,234.31. Homes are expensive. So they're saying basically here, notice that the amount of the loan balance reduction during the second 10 years was very considerably bigger than the amount of the loan balance during the loan balance reduction during the first 10 years. And yeah, I mean, there is, obviously we went from only 50,000 being gone from the first 10 years, right? Because you were still at 200,000, but now we are at least less than half. I was kind of hoping we'd be less than $100,000, but obviously the calculation is telling us no. So yeah, I mean, we did go down less than half by the time we reached that last 10 years, because you're from 250, 125 would be the half of that. So yeah, we're definitely less than that. So they are asking us, why does the loan balance decrease at a faster and faster pace the longer that the loan has been in repayment? So why does the loan balance decrease at a faster and faster pace the longer you are making these loan repayments? Well, I just talked about it. What's happening here? Yeah, because the longer you keep making those payments, towards the end, it's going to start going towards the principal and not so much of the interest. So let me go back to that first graph we had. So this is what's happening. Remember, in those first few years, most of your money is going towards the interest, very little is going towards the principal. But as more and more time, and this was only over a 10-year time period, right? Think about if we extend this out to 30 years, how that would look like, but kind of like more than half of way of the loan through, you will see now a lot of our payments are going towards the principal and only a small amount is going towards the interest. So that's actually what's happening. The other thing is, and we will be talking about this because we are going to talk about exponential functions later on in this course. Remember how I was telling you that's a negative exponent that you have in this formula? So the negative, of course, is because the value is decreasing, right? And then remember, exponential growth works not in a straight line, it's got that curve. So in this case, your curve would actually be going downwards. So if we were to like graph this guy, your curve would look something like this. So the idea is, yeah, we are making higher payments when we start out, or, paying higher towards the interest. But then as time goes by, because of that negative exponent, you're going to be making less and less money, payments towards the interest, and more of that chunk starts going towards your principal. So that's the other reason why, as more time went by, we saw our loan amount decrease significantly than it did in that first 10 years. So that's kind of what's happening for that last question. There we go. So questions on this example over here, guys? Anybody on Zoom have a question on this? No? Doing okay so far? Yeah? Alrighty. Okay, so that was calculating how much loan you have left over, what will your balance be as time goes by. Alrighty, so we had kind of also talked about how you can also think of credit cards as a loan. So let's take a look at this guy here. So yeah, they definitely help you build a credit score. They can be a short-term loan, or as I was telling you, I kind of use it as an alternative to physical cash. because it's easier to dispute charges with credit card companies than your bank and a debit card. And of course, once the cash is gone, it's gone, right? But it is advisable to pay off your credit card each month because those interest rates are much, much, much higher than any conventional loans, right? Because those ones, if you have experience, you will see most of them usually start at like 18.99%, or, once that federal rate changes, and those rates will also change. So sometimes they can be like 22% point something, right? Or 25% at some of the worst ones. And then, your credit score also makes a big difference of if you can get a low interest credit card or not, or if you are like new. When I was first starting out, they wouldn't even give me a credit card because I had just come to the US. I had no credit history, right? They're like, you're nobody. We don't know who you are. You're barely making any money. I was an undergrad, right? So I worked in the college bookstore. It's not like I was making. And remember, you guys were probably not even born, so I don't know who I'm telling you to remember. The minimum wage was $5.15. And it stayed like that for years. I started doing full-time job and that minimum wage did not change. Like maybe to $5.35 or something, but not a whole lot. So yeah, the credit card company's gonna be like, you're a poor college student. Why would we give you a credit card? Because you're probably gonna borrow all the money and never be able to pay it back, right? So they have to protect their own investments. So yeah, first you have to build that, but then once you're starting out, they will start you out with those higher interest credit cards. So the 25%, so 27%. But then they see, okay, are you making regular payments? Are you not defaulting on those payments? You're not being late, and those kind of things. But once you get there, then you can get at a decent interest rate, but it is still going to be higher than, those 3%, 5%, 6% we have been talking about as loan interest rates, because these guys will always be much higher. Also, there can be expensive fees applied if you keep carrying a balance. So remember, I had used that example of a friend of mine who was only paying the minimum payments, and then they ended up accruing all that debt over several years. So because, they charge you a high finance charge also if you keep that balance at the end of each month. So let's say if you borrowed, and I'm just gonna go with a random number here. Let's say we borrowed $1,200 off a credit card. Maybe we bought like plane tickets on it or a vacation package or, something like really expensive. Or maybe it was just something regular, car broke down and we had to fix that on a credit card. But now at the end of the month, we're not able to pay off that entire balance, right? So maybe out of the 1,200 that we borrowed, you paid off maybe 800 because that's what you had. And then you're like, I'm going to leave that extra 400 on there. But now the company's like, yay, I get to charge you a finance charge on that 400 that you're going to do for the next billing cycle. So now that is where you're going to be paying that interest rate of whatever percentage you have, right? 25% or whatever. So that's going to add up. And the worst would be if we paid no payment, right? Then you get charged that late payment fees if you don't make a payment. So that kind of adds up. But if you still make that $800 payment, you're not going to be charged the late fee. You're just going to be charged whatever balance you left in your account, going to the next billing cycle. So those fees also can be pretty high, basically. So what happens is you're basically building debt on top of debt, right? So you're kind of growing that debt. So yeah, they are talking about how credit cards are a common source of loan money. So that would mean they're a common source of debt also. Yeah, and they're talking about like you can relatively easily get a credit card, but my experience has not been that it can be easy to get a credit card. But once you get it, using it is very easy because you don't see that money reducing from your account, right? Like if you would see in your checking account. So a lot of times it's like out of sight, out of mind, right? So you may not be thinking, oh, that's building up unless you go log into your credit card account and then you see what your balance is. So yeah, in those sense, I would say they can be dangerous in a way, right? If you're not able to keep track of your expenses. So the idea here is, okay, so yeah, they're saying it's easier than getting like a mortgage loan, and I do agree with that. It would be easier to apply for a credit card than a loan to a house. All right, so there are some drawbacks in terms of typically higher interest rate, but also some structural differences. So let's take a look at this example here. How would we say that name? Bilkis? No complaints on how I'm pronouncing that? And if it is incorrect, I apologize. I think we'll just call them Bill. That's a safer, because there's a BIL in there. So they get a credit card with a 17.99% APR compounded daily. And yeah, that's the other thing. A lot of times the compounding is daily, not monthly on credit cards also. So she uses to buy a $900 plane ticket, okay? So $900 plane ticket. She does not make any payments during the interest-free grace period. The first payment is due 35 days after the grace period has ended. So following the fine print in the agreement, the minimum payment is calculated to be 1% of the outstanding balance after applying the APR. And that can be the 1% or $25, whichever is larger. So they want to know what will the outstanding balance be, what will her minimum payment be, and if she pays the minimum balance, minimum payment, what will the new balance be? Okay, so lots of different things happening in there. So we do know this is a 17.99% APR. And since we are talking about compounding daily, your time frame is also going to be in number of days. So she borrows $900, and this is your basic, simple compounding interest formula, guys, that's being used here. So A equals P times 1 plus R divided by N, and then N times T on the exponent, right? I actually just want to write NT, not N times T, but yeah, it's multiplication. So $900 is your principal because that's what she's borrowing. You have a 17.99% APR, so as a decimal, that's 0.1799. We're talking about the compounding period being daily, so that's your N value of 365. So that's where this guy is coming from. And then we're basically saying the first payment is due 35 days after the grace period has ended, right? So obviously they're not going to be calculating any interest during the grace period. So we're not saying, you know, you got the credit card today or you made the charge of 900 today, grace period, and then 35, right? It's just whenever the grace period ends, they're counting the 35 days from that. So why is the exponent only 35? Because it's supposed to be N times T, right? So N is 365. T is typically supposed to be in years, right? But they're saying this is 35 days. So if you had to take 35 days and convert it into a year, you would do 35 times 365. So now think about it. If you are doing N times T, well, N is 365. T is 35 over 365. So, you know, 365 cancel each other out and you're left with just the value of 35. So that's why your exponent is only 35. So the math is there, just not showing you how they came up with that. Okay, but remember, they're still doing N times T on that exponent. So once we put all of that into our little formula here, you can see this tells us that Bill Kiss will have to pay $915.66. And, you know, obviously you can use that built-in function also. So 0.1799, so that's R divided by N on the rate over here, and then N times T, again, same calculation, will give you 35. Since we are not talking about making regular payments here, that PMT value is going to be 0, and then of course we borrowed $900, so that's going to be our present value. And you can see that will give us the same number of $915.66 over here. And then now if you think about, they are telling us, okay, let me erase that writing. They did tell us that at that period, looking at the fine print from the credit card agreement, the minimum payment is calculated to be 1% of the outstanding balance after you have applied the APR. And then depending on what dollar amount it comes out to, if that 1% is less than $25, then you will charge $25. Because they're saying go with the larger amount, right? So now we have to figure out what that 1% is going to be. So remember, our balance after we applied the APR is $915.66. So on that dollar amount is where you're calculating that 1%, which you can see is coming out to be $9.16. So obviously, they are actually going to do a minimum payment of $25 instead of $9.16 because that's the larger amount. So then Bilkis will need to make a payment of $25. And that means once you make that payment, the balance on the account will be $890.66. So you can see how this was a two-tiered calculation, right? We first had to figure out what the balance in the account would be once that APR is applied. And then based on that balance, you calculated the 1%. If that dollar amount had come out to be larger than 25, then that's what the minimum payment would have been. But since it only came out to be $9.16, they're like, no, the minimum payment's gotta be 25. And then subtract that and you get your balance for that account. So let's see if we can find something similar in here on a credit card question. Credit card. I think mortgages, I'm not really seeing something on that credit card. I thought they had it. No, these ones, we've already done similar examples, Pat, I just don't want to repeat the same example. All right, maybe I can find something from our homework. All right, so here they're just kind of giving you a summary of all the different functions we have talked about. So of course, you've got the future value formula, FV, you've got the present value, the payments, and then remember, we had also talked about effective rate. The other one is they're talking about the simple interest formula. So that first one, the principal plus principal rate time is the simple interest formula. This one, remember, principal times the EXP was the continuous compounding formula, where you use the natural number E. So that's what this guy is for continuous compounding. And then they're just giving you the breakdown of the different arguments you put inside these. For the spreadsheet, they're just again kind of giving you examples of when you would use which formulas. Of course, if you're trying to find those regular payments, that's the PMD. If you're trying to compare, accounts that may be at different compounding periods like we had seen, or different interest rates and different compounding periods, then you would use the effective rate because that gives you the annual percentage yield. So then you can compare and say which account is going to give me a higher interest rate maybe. If you are trying to figure out how much you need to deposit now, how much you need to borrow on your loan, or what your remaining loan balance will be, in those examples, you use the present value PV function. Like I said, the principal plus principal rate and time, which actually looks like this, is the simple interest formula, or you can say P on the outside, 1 plus RT is going to be your simple interest formula. FV, of course, is for the compound interest, and then remember I called it the PERT formula. That's what this guy is for the continuous compounding. Now, obviously, you guys are free to write whatever you want to write on your note cards, because you gotta see like what you would need to remember on the exam, and what you need to have like in front of your eyes, right? So maybe some things you remember, some things you wanna write down. But I would definitely or that you have somewhere the formulas written down, or at least you know like what I'm supposed to type in into my FV, PV, PMT, you know, those kind of functions. So you know what the argument, because just knowing the name of the function is not gonna be enough, right? You need to know what those arguments are, what are those values I put inside those parentheses. So those will be some things you definitely need to keep track of. And then this guy over here is just listing the actual mathematical formulas that these functions are based off of. And again, for that simple interest. So the loans is the only one that we did not break down, but other than that, we used all the other functions formulas that you see here. So for this guy, I would also include A equals P on the outside, 1 plus R times T. So kind of just rewriting this guy. Then you've got your compound interest, your continuous compounding, and then your savings plans. Formulas in there. And again, like I said, it is your choice, your decision, which ones you want to write down, which ones you don't want to write down. If you're only using spreadsheet, then you may not even have to worry about the basic formulas themselves. If you're not going to be using the spreadsheet, then of course, formulas is the only other way to go about doing those. And then just again, a quick review on when to use which formula, what questions to ask yourself, you know, what am I basically trying to find? And then you can kind of see how they're guiding you through that. So I'll let you guys read that on your own time. But questions on, just I guess, chapter 2 in general. Let me see if I can find a credit card. See that first example. When you don't charge anything. That seems to be- Oh, why not? Number 11 looks scary enough. So let's take a look at this guy over here. So this is talking about Henry's monthly minimum credit card payment is calculated by first applying 15% APR, which is compounded monthly. So you will see this one is specifically telling us compounded monthly, whereas the example in the textbook was compounded daily. So make sure you're looking at those numbers. Monthly to the outstanding loan amount, and then he pays 2% of that figure. Currently, Henry has a balance of, oh lordy, $18,375. What will his monthly payment be? So you can see they're giving you that nice little hint. Start by applying the 15% APR for the monthly, and then you take 2% of that number. So again, which formula are we using? FV, PV, PMT? To find out Henry's monthly payment.
PMT,
Will it be PMT? What do we think?
that's for finding.
The regular payments, right? Alrighty, very good. So yeah, let's take a look at PMT here. Because they're telling us he has a balance of 18,375. So we don't really need to find out what his balance is going to be. Okay, so are you gonna let me do a copy paste on this? Maybe, yes, no. This was number 11 from. Oh, yeah, it did, awesome. So rate of interest is 15%. So I'm gonna change that to a percentage. And then of course, make sure it's 15%. Alrighty. Compounded monthly, so your end value is going to be 12. Current balance is 15,375. Yeah, because it's a loan we're paying, so this will be our principal, and then the future value should come down to be 0 like we've done in the other examples. Am I missing anything else? So what would we assume for the time? Yeah, I mean, did they tell us anything in the other parts? For time? Not really. Like he's gonna pay it off in so many years or what. Let's move this guy here. All right, so for now, we'll just assume it's gonna be probably less than a year. Alrighty, so we are finding the regular monthly payments he needs to make. Which is gonna be the PM, and actually I'm gonna start by putting a negative sign after the equal to, so again, we can get a positive amount. EMT. Our rate will be R divided by N, yes? That's what we've done, okay. Now for the number of periods, what are you going to do? Just 12?
Just 12 times one.
What did we do in that credit card example?
Usually we do the N times T,
Right,
but since T in this case is just one,
yeah.
it'd be 12.
Yeah, because in that example in the textbook, let me see if I can get us there. Since they were doing it in days, remember how I'd shown you, you did N times T and it still came out to be 35. So in this case, I guess the idea is you would pay it off within that year, right? So 12 times 1, which should be 12. And we'll see if our answer comes out incorrect, we'll know that, somewhere something didn't work out. All right, present value is the balance on the credit card he has so far. Yeah, and then the last one, future value, of course, since it's a loan, we want to make sure when you pay it off, it comes down to be 0. So I will leave those arguments in there so you guys can see. So we took R divided by N, comma, N times T, comma, P, comma, 0. Yeah? Okay, so you calculated that 15% APR. Then remember, but basically we are saying on top of that, he has to pay that 2% also, right? And you can see in your hint also, they said start by calculating the 15% for that monthly payment and then take 2% of that number. So this is where 2% of the payment, right, of the D value. So this is where you are going to do the payment we just calculated times 2%. And remember, you have to put this as a decimal. So you can either do that here, or if you wanted to create a separate 2% line, you can do that also. So 2% of the payment, you can create that 2% like we did with the 15%. And then you can click on that cell. So it's really up to you, however you want to do it. So to calculate 2% of D, we take the D amount and multiply it with either as a decimal. So if you're typing in, that would be 0.02, right? Or you can do the formatting like I did. And it looks like 2% of that payment is coming out to be $33.17. Questions on how we came up with that number? Okay, if not, let's check and see if we did that math correctly. So $33.17. No, it's incorrect. All right, where did we go wrong? Henry's monthly minimum credit card payment is calculated by first applying 15%, which is compounded monthly to the outstanding loan amount, which is the $18,375. And then he pays 2% of that. So yeah, we did do 15% divided by monthly, which is 12. Then we did monthly. My only other argument would be instead of 12, do we do the exponent here? So you know where we did, what did I do? Oh my God, 12. Okay. R divided by N, then we do N times T. No, it's still the same math. That was not the problem. The only concern I can see is in that exponent. I think everything else we did correctly. So what can we change for that N times T on the exponent? Because right now we're calculating it for 12 months over a year. I'm kind of thinking, what if we had to do this only for 1 month? Like make that N times T value just together 1. We can try, right? And if it's wrong, it's wrong. Payment. Because nobody can afford paying $372.
The monthly minimum payment would not be more than actual loan value.
Say that again, Samuel.
The monthly minimum payment would not be more than the actual loan value.
Well, but $372.09 is not more than the loan value. The 18,604 is what with the interest, which is not actually wrong.
Yeah.
Because you are obviously leaving the money in the credit card. So they're like, oh yeah, I'm gonna charge my APR on this, right? Because you're leaving it with them. So they're like, you know, if you're gonna leave that money, you're not gonna pay off that loan. Of course, we're gonna charge you interest. So you know what? Let's try. I mean, if it's wrong, it's wrong. 372.09. 372.09. Okay.
Go back through that formula again.
Yes, and that's exactly where I was headed, so good. All right, so basically, we have PMT, R divided by N, right? So that's not gonna change because you are going to charge that interest of 15% over a 12-month period, right? So that was okay. Your principal of the 18,375 was okay. Your future value of 0 is okay. So the only thing we changed was that second argument where you see the number 1. And that is because we're basically saying you are calculating, and that's this one I'm talking about here, people on Zoom. If I can get my little red dot to stay. So instead of doing N times T, which is what I had done in the first calculation, you're basically saying calculate if you were going to pay this off in just 1 month. So not like over an entire year, but you're just going to pay it off in 1 month. So that's why, you know, because how they had done 35 as the exponent in the textbook example, because they were saying at the end of 35 days, you'd be paying the $900 that Bilkis had borrowed. So this is the same idea here. We're basically saying, okay, what if at the end of the month, Henry decides to pay off this whole balance he has, which is the 18,375 plus whatever his interest is being charged at that 15%. So that's why we are changing that exponent do one. And remember, that's kind of why I wanted to do a credit card example, because these are a little bit different than your traditional loans, right? Because traditional loans, you can keep them for 3, 4, 5 years if it's a car loan, 30 years if it's a mortgage loan. But obviously, we cannot do that with credit cards. So that's like the one thing you guys will need to be mindful of as you're going through this. Okay, so that was our monthly payment. So it looks like, and now that I'm kind of thinking about this, at $18,000 balance, you are gonna have, right? A pretty big chunk of monthly payments, because otherwise, how are you gonna pay off that loan if you kept doing like $33, which is what we got before? So it kind of makes sense that you would have pretty hefty payments to pay off. I mean, it's a pretty large amount. All right, so assuming that he only pays the minimum, what will his new balance be? Okay, so take the loan with the 15% added on, we already did that, and then subtract the payment you just found on the first answer. So are we just saying you do one minimum payment and what the balance will be? So let's try that. Take the loan. Okay, so you are taking this new amount that we came up with. Was figuring out the payment. Okay, I want to try something to see what the future value of the loan would be. So I'm going to use the FV formula here. Rate, of course, would still be R divided by N. I'm still going to keep my number of periods at 1 for now. Our payment amount of 0, like we did in the example, and then present value of 18,375. Oh, okay, so it is the same as the number here. Okay, all right, so if the future value of our loan is basically going to be that $18,604.69, remaining loan balance. So you are basically gonna take the 18,604, subtract the 2% payment we calculated before, the 372. And that should tell us what the balance will be, right? So you make that one minimum amount payment due, and we are left with 18,232.59. 18,232.59. 18,232.59. So let's check that. All right, so that's what you're doing. Which means you could have technically done that with these two numbers here also. So subtracting the 18,604.69 with the 372.09 to come up with your remaining loan balance. And then let's see what's the last one. Oh, okay, so the last question is how much did his debt decrease by? And that's taking the original loan with the new balance, right? So that's going to be obviously, what do they call it? Debt decrease. Okay, so original subtracted from the new loan value. So 18,604.69 minus the 18,375. Remember, part of that 372 went towards the interest, right? So your principal at this point only went down by 229.69. So 229.60. And what's wrong? How much did his debt decrease by? Yeah, the debt decreased by, right? Original loan to the new loan. Oh, no, sorry. What did I do? Oh, no, sorry. I know what I did. My bad. because he did pay the 372. Sorry, his new remaining loan balance was 18,232. So since this guy's the larger number, 18,375 minus the remaining loan balance. So sorry, 142.41. 142. There we go. So yeah, sorry, I used the wrong number in that. So it should be after that minimum payment has been made. So you're taking the answer from part B and then comparing that with the original loan amount to come up with the by how much the debt has decreased present. So 142.41. That terminology similar to what they're using in the exam. Question on this one here? None of the others look that scary to me, but my scary might not be the same as your scary. Is there anything you guys are seeing in that homework section that you would like me to go over? Three? Four. Yeah, the section we just finished talking, yeah. Is there something from 2.3 you wanna look at? No, okay, I was just. And I can give you guys a second to look through and see if there's any questions you wanna ask. Or I can pick one. Either one.
Trying to figure out 11. Just the first part.
Oh, what, hello? 11 first part. What's your compounding period?
Well,
So monthly?
Yeah, monthly.
So in that calculation, make your number of periods just one. So if you're using the PMT or FV formula, the first one is R divided by N in that function, but the second one should be, your exponent should just be one. The number of periods argument. Okay, if you are not telling me, I'm not seeing anything come through on chat either from my Zoomies. Let's do one of these down payment examples. Yeah, let's do this one. This one has 4 parts to it. So we're looking at number 7 over here, guys. This one is talking about Janelle bought a home for $400,000, paying 14% as a down payment. Financing the rest at 5.8% interest for 30 years, round answers to nearest cent. Okay, so let's do number 7. The math. This is Janelle bought a home financing for 30 years. Okay. First question is asking us, how much money did Janelle pay as down payment? So they're telling us they are paying 14% as a down payment. So how do we calculate the down payment? So we know the home value was $400,000. The down payment is 14%. Oh, 14%. What else? Financing at 5.8%. 30 years, of course. rate time. And again, since we're talking about a mortgage, by default, we know it's gonna be monthly payments, right? So the first question is asking us to calculate the down payment. How much will Janelle put down for down payment? How do we calculate that 14%? Oh, come on, we talked about percentages in 1.3. Sorry? Say that again? No, but how would you calculate it?
Multiply the 400,000 by 14.
Get that, perfect. You take the value of the home, multiply it by 14%. Ooh, that's a big chunk, right? $56,000 is what the down payment should be. So let's check that number. See, simple, right? 14% multiplied by the value of the home. Typically, I think the down payment can be just 1 or 2%, right? If I'm not mistaken, is what I've been told. I don't know. All right, so that's how you're doing that. Now they want to know what was the original amount financed. So if Janelle is making a $56,000 down payment, how much are they financing? What do you think? Subtract? There you go. Yeah, because basically the idea is if upfront, down payment means what you're paying upfront, right? At the time of purchase. So what did they call it again? How much was the amount financed? Okay. Fine. Will be the 400, which is the value of the home, minus the down payment that Janelle has made. So that means you are only going to be borrowing $344,000. 1, 2, 3. All right, that looks good. What will be the monthly payment? What formula would we use to calculate the payment here, guys? And again, let me start out by putting a negative first and then the payment function. All right, so your rate, of course, is R divided by N, comma. Now, in this case, what will our number of periods be? Is it gonna be like we did for the credit card, or is it gonna be what we were doing before? N times T. If we're talking about mortgaging a home. Well, then,
Time, 30 years.
yeah, so you will be going back to the original calculation like we were doing for other loan and savings accounts. So N times T, not the credit card calculation. So N times T, comma, our present value will be the 400,000 or the 344? Yes, because that's how much we are borrowing on the loan. So 344,000, and then of course, future value means we've paid off the loan, so that should be 0. Yeah. So let's see, our payment looks like for Janelle is coming out $2,018.43. $2,018.43. Yay! I was very nervous. I was like, oh, please work, please work. So I'm glad it did. And then I guess that brings us to the last part, which is saying if Janelle makes these payments every month for 30 years, which means for the length of the loan, determine the total amount of money she will spend on this home. And you also want to include the down payment in your answer. So how do we calculate how much money Janelle will end up putting towards this home? So total amount of money spent, total money spent. Sure, that makes sense. how do we calculate how much money Janelle has actually paid towards this house, towards this home?
Monthly payment times N times T plus the down payment.
Yes, very nice. So let's do that over here. So it's going to be monthly payment, which technically we call it D, times every month, in a given year, so N, times the total length of the loan, so 30 years. And then to that, you add, as you said, the down payment. So this will be monthly payment times N times T plus the down payment of that 14%, $56,000. Oh, good Lord. 782. 634.96. That is double, almost double the value of the house. I mean, they are saying the home was $400,000, right? And this is just shy of being $800,000. That is scary. I guess so. Crazy. That's why I love living in rental, people. It's less scary. But you guys can kind of see how that math worked out, right? Like you started out with the 14% for the down payment. Then you did, what was the amount being financed? Then calculating the monthly payment based on just the financing, right? Because obviously the 56,000 has already been paid upfront, and then figuring out what was the total value to the person after they purchased the home, because that's where the interest and everything gets calculated and all of that, right? Okay, I know you guys are ready to leave, and I am okay with you wanting to leave also, but let's answer some questions. So please remember, you cannot take the exam on Zoom. And hopefully people on Zoom, you are understanding what I'm saying. If you need to take the exam at the testing center and you know who you are, do it today. Make an appointment with them. If you can get your exam at the same time as class, that will be great. So while the classmates are taking the test in class, those of you will be here with me, and then those of you who need to be in the testing center, if you can do it at the same time, that'd be great. If not, you need to let me know the time that you will be taking the exam, because I will need to send all that information out to the testing center, okay? Now, this is not an optional thing. You have to be pre-approved to be taking the test at the testing center. So it's not like you can randomly come and say, hey, Mr. Rook, I'm gonna go to the testing center. No, you have to have accommodations with that, okay? Note card, front and back, one single note card, right? So again, if you need some more, I've got these here. You can, are they rolled on both sides? No, they're playing on one side. But that's the size you're allowed to use, nothing bigger. You go smaller, that's your choice, but nothing bigger than this size, okay? And handheld calculators are okay. Spreadsheet is okay, and I would recommend using Google Sheets because that's easier for you to share with me. And then that way you don't have to like download it and email it to me. I can just basically go in, click on the link, and I can see this is the math you did, and I can follow your math if you're using spreadsheets. If you do not share your spreadsheet with me, I cannot give you full credit on any of the exam questions, okay? Because I do need to see your calculations. And then I'll provide you with scratch paper in case you just need something to, do scratch work on. Anything I'm missing that I need to tell you about the exam?
Be excluding the income tax section.
Yeah, it's not a required, learning outcome for us, so yeah, we're not doing it. So Tuesday is the exam. Tuesday is the exam, yes, I guess I should remind you that. Biconditionals included in it? Yes, biconditionals are included in it. You will see I have created practice, assignment that's not for a grade. It's literally what it says. It's for practice. So if you didn't want to like mess up with your homework, you've already got the 90%, 100% grade on it, and you're like, I don't want to go back and use that for practice, go do the practice section, because that will not count for a grade. So even if you get a 0 on it, it's not going to affect your overall grade. So I didn't want you to feel like panicky, like, oh, this is going to mess up my grade, so I don't want to go in and look at it. So that's why the practice is there, okay?
Is the formatting gonna be the same as homework where?
Yes.
I guess all the whole time?
No,
For one time.
one trial on each question, because obviously, homework is different because you practice. But exam is going to be one version, one trial. After you submit the entire test, not on each question, like we do for homework. So yeah, that formatting will be different.
And it'll be on the.
It will be on My Open Math,
Okay.
but like I said, you're still gonna be submitting like the spreadsheet and stuff like that. So yeah. Any other questions coming to mind that I may not have? Anybody on Zoom have a question on that? So please make sure you're in class with me on Tuesday, okay? All right, if you guys don't have any questions, then I will see you guys on Tuesday morning. Take care, everyone. Be careful. Yes. Okay, so, that's a good one. I am still trying to narrow down your test yet. Right now it has 50 questions. But you will not have 50 questions on the day of the exam because I will narrow it down. Oh, I wish I could give you that, but it is not gonna be longer than our class time. I'm not gonna like have you here stay till like noon, trying to finish the exam. You can if you wanted to. It'll probably time you out at that point, but,
I failed it.
you-
Are you gonna
Um,
try?